So before we talk about 2.3, I do want to talk about some absolute value inequalities and see if you have some understanding there, or if you don't, you can learn some new stuff. And I specifically want to talk about this form here. So we have an absolute value and it's an inequality. And this symbol here, if you haven't seen it before, is delta, a Greek symbol that you're going to be seeing a lot going forward, delta. And another symbol we will be using is epsilon, which you'll see in the next video. And so I want to talk about this absolute value inequality. And let's just start with one that has some numbers in it. And the first thing I want to talk about is how to get rid of the absolute value. And how you can do that is recognize when it's positive and when it's negative. So for instance, if we look at this expression x minus 2, we know this expression will always be positive when x is greater than 2. Now I do have an equal sign on both these expressions, which I'll get to in a second, but if x minus 2 is positive, then the absolute value sign does nothing, and we can just get rid of it. So again, if x is greater than 2, that means this expression is positive, which means the absolute value sign is doing nothing, and so we can just get rid of it. Now, what if x is less than 2? So that's this case over here. If x is less than 2, then this quantity will be negative. X minus 2 will be negative. And then the absolute value turns that to a positive. Well, how can we make a negative number positive? We can multiply it by a minus sign. So if we know x is less than 2, then we can write the absolute value sign as simply a minus then, and we can get rid of the absolute value. Because we know x minus 2, we know it's going to be a negative number, so if we simply multiply by a minus sign, that forces it positive, which is what the absolute value sign does. And we can always do this. We can always break an absolute value into two expressions. And this is the first thing going forward that I want you to be aware of if you aren't, is that we can always break an absolute value into two inequalities. And here I did it then with the letters here. If we know x minus l, if we know this is positive, then we can just get rid of the absolute value. And if we know x minus l is going to be negative, then we can just multiply by a minus sign to make that positive again. And so we can always take this expression here and break it down into these two expressions here. Now, something else that we can do looking back to the right is now that we have these two inequalities here, we can actually solve for them. So let me solve for this one, just adding 2 to both sides, and we'll get x is less than 7. And on this right side here, I'm going to distribute the minus signs. We'd have minus x plus 2, and then we can subtract that 2 from both sides and get this expression. Now, if you recall, if we multiply both sides by a minus, that switches the direction of the inequality. And so we get this expression here then. And what can we do with these two expressions? Well, we can actually combine these back into a double inequality. So notice this says x is less than 7. So right here, x is less than 7. But x also has to be greater than minus 3. So x is also greater than minus 3. So not only can we break an absolute value down into two expressions, but we can eventually combine those expressions again to give us a double inequality. And this is something else that's useful to know, is that this absolute value expression here, this can be broken down into a double inequality right here. And now I am using just the letters here. And notice how straightforward this is. So our expression is x minus L is less than delta. And we still have that. Here's x minus L is less than delta. But once we take away the absolute value sign, x minus L has to also be greater than minus delta. And so it's a pretty easy transition to make, just to go from here to here. And it's something that can be useful to do going forward. Now, I do want to mention really fast, depending on how you, looking at the right sides here, depending on how you've learned absolute values, is I know some teachers have said that when you solve absolute values, you put the minus sign on the 5 here, and that's only true if you have an equal sign. And technically, the minus sign is always connected with the absolute value. But if you have an equal sign, then of course you can bring the minus sign over to the 5 side without penalty. But when we have inequalities, moving the minus sign to the other side actually changes direction of inequalities. So you got to be careful here. If you're used to putting the minus sign on the right side, you can't do that with inequalities. Technically, the minus sign has to be on a side that has the absolute value. Now, these two things are both very important for all your future of math. If you're going to be encountering absolute values, how do you deal with that? Well, you can break it into 2 equations is one way you can deal with it, or you could express it as a double inequality. And just reading my notes here, I do want to make one quick technical change here. I do have equations written here. This is technically, though, inequalities, since I'm using an inequality sign and not an equal sign. So just a little technicality there. Change that word to inequalities. So there is a third thing that I want to talk about here that's going to be also very important for 2.3. And so I want to start with the double inequality here. So here's our double inequality. Remember, the double inequality is the same thing as the absolute value inequality. They both express the same thing. It's just written differently. And I'm going to take this expression and add L to both sides. So that's all I did here, is I just added L to both sides. And we're going to use this one and look at a number line. So L plus delta, this is the largest value in the interval. And L minus delta is the smallest value in the interval. And notice this interval has a length of 2 delta. So if we go delta from the right, then we'll be at L. And if we go another delta, we'll be at L plus delta. And this L that you're seeing is the center position of this interval. And again, try to remember, I wanted to start with the double inequality because I think that's a little bit easier to understand. Remember, this double inequality means also this absolute value inequality. They express the same thing. So notice in this absolute value inequality that this L represents the center point of the interval. And that's always true. And what about this delta? Now look, delta represents the maximum distance we can go from L. We can either go a distance delta to the right or a distance delta to the left. Delta represents the maximum distance from L. And sometimes this is called the tolerance. How much are you willing to tolerate your number being away from L? And this represents then this interval with L at the center and delta representing then how far we can go from L. And this is the third thing that I want to add to our list here, is that this expression, this absolute value inequality, what you should burn into your brain here is that L represents the center of the interval, and that delta represents the maximum distance that you can go from L, sometimes called the tolerance. So let's check out some examples doing this. So I'm going to write this expression with a C now, and that's because I'm starting to work towards the book notation you'll see in 2.3. So the book uses L for the y-axis, and they use C for the x-axis. And again, I'll talk more about this in the next video. So we have C as our center of our interval. Here is the picture of what it looks like. And what we're going to do is squeeze this into a given interval. So I'm going to give this interval on the bottom. I'm just giving it to you. This interval is from 2 to 7, and I'm going to tell you that the center point is 5. So I'm just going to tell you that. And so we know then that C equals 5. So I'll just stick it down here. So here's our expression with C equals 5 in it. And let's look at the number line. Remember, 5 is the center value. And if we look, the maximum distance we can go to the right is 2. And so delta must be 2 here. Now if we look at the left, if we see 5 to 2, we see this distance is 3. But if we chose a delta of 3, then on the right side, that would allow us to go to 8. And 8 would be outside the interval. So delta is always going to be the shortest distance from the center. So we can go a delta 2 to the right. We can go a delta 2 to the left. And so our delta, I just replace it down here, is 2. So this equation here expresses this interval from 3 to 7. Now you may be asking yourself, well, that doesn't represent the interval 2 to 7, it's only 3 to 7. And that's fine. What we're interested in here is squeezing this interval into this one. We're not interested in making them the same. We want to squeeze it into here. So look at this picture here. Look at this interval. And let me just fill it in with a color. What we're doing is we're taking this interval and we're going to squeeze it into this one. So we'll align the C's up, and then we want to choose a delta so that we can squeeze this interval in here. And if we choose a delta of 2, we can do that. And there's where the interval would be squeezed into then. So our interval gets squeezed into 3 to 7. And what we want here is we want the interval of the absolute value. We want it to fit within the interval given. So that's the kind of little game we're playing here, is we want to take the absolute value expression and squeeze that interval into something that's being given to us. So let's try another example. Here again is our absolute value inequality expression for this interval. Again, x is somewhere in this interval. And now I'm going to give you an interval. So I'm just going to give you the interval 1 to 5. And I'm going to tell you the center point is 4. And now what you want to do is choose a delta that will squeeze this interval into this one. And you have to have the C's lined up. So we want to choose a delta that'll squeeze it in there. So first off, Since I'm telling you C is 4, we can identify that and plug it into the equation. So I'll just do that right here. Here's our absolute value inequality, and I'm just plugging in C equals 4. And now the interval can only go to 5, because once we go past 5, we're outside the interval. We don't want that. We want to stay within it, which means the maximum distance we can go from C is 1. That's the maximum distance we can go from C to stay within the interval. Again, if we chose 4 to 1, if we chose a distance of 3, well, on the right side, that would get us to 7, which is outside the interval. We don't want that. We want to stay within it. And so we choose the shortest distance from C, and that will get us our delta. And so I plug that in at the bottom here, delta equals 1. And so this equation here, this inequality here, represents this interval, squeezed in. And let me color that in again. So here's our interval, and then we're squeezing it in right here. And if we choose a delta of 1, that will squeeze that into that interval then. And another way the book will ask you these questions is to give you a graph. Now I know this graph may look a little complicated. I'll talk more about it in the next video. But all we care about here is the interval given. They're giving us the interval 9/16 to 25/16, and they're telling us the center point is 1. So here's our expression. We can immediately identify that C is 1. So let's plug that in. So C is 1. And now we want to look. What is the shortest distance from 1? So we want to go 1 to the left. So let's look at this distance here. And that distance, 1 minus 9/16, is 7/16. So that distance to the left there. And let's look at what the distance is to the right. And we can see that that's 25/16 minus 1. We can see that is 9/16. And now we choose the shorter distance. And so 7/16 is shorter than our 9/16. So the maximum delta we can choose is the shortest distance from C. And that's 7/16. And let me just color in on the graph where that would be. So here is our interval centered at 1, and it goes left 7/16, and it goes right 7/16, and it's squeezed into the interval given. Now, I do want to make a final comment here about squeezing these intervals in. It is true that we could choose smaller deltas. So if I chose a smaller delta, if we look at the brown line here, if I chose a smaller delta, I could make this interval smaller and still satisfy being within this interval. So that's true. But for the homework, so that my math lab can grade your answer, the homework does want the maximum delta. So the maximum delta means this brown line will always touch then one of these endpoints. So just to say all that again, especially for the homework to make sure you're getting the right answers, is you're going to be choosing a delta, and then you choose the maximum delta, and that maximum delta will always be the shortest distance from C. And then that will squeeze this interval into the information given. And we will discuss why we want to do this in the next video.